And continuing on with page number 3, problem number 21. So this one we are solving the following equations, round to 3 decimal places as needed, and be sure to check for extraneous solutions. So at the end we will always just check to see if we plug it back in, if it gives us a real number or not. So first thing we have to do is we look at these and we're like, okay, so these in exponential form. The way that I can solve this is if we have the same base, then the exponents are the same. So if I can rewrite one in terms of the other, that would be really helpful. And I recognize that 27 can be written as the power of 3. So I'm going to change 27 to 3 to the third, because 3 to the third is 27, and then that's multiplied by the x also. Now they have the same base, so I just rewrite it with the exponents equaling each other. So 2x plus 1 equals x. If I minus an x from both sides, I get x over here. And if I minus a 1 from both sides, I get x equals negative 1, which is my answer. Now, I just have to check, if I put a negative 1 in here, will that cause problems? No, it might give some fractions, but it's not going to make any undefined values. So we're good. Next one, I have to recognize that this exponent is not alone. So the first thing I want to do is add a 3 to both sides so that it is alone. So I have 5 to the x plus 4 equals 21. Now, the x is in the exponent. So how I have to get rid of this base is by taking the log of both sides. So if I do the log of both sides, and if I do log of base 5, then it will cancel out that base of 5 there. And I have to do, I don't have enough room here, so I'm just going to write log base 5 multiplied by the 21 also. So there, the log base 5 and 5 cancels out, and I just get x plus 4 equals log base 5 of 21. Now, the only thing I need to do to get that x alone is subtract a 4 from both sides. And then I grab a calculator, and I just put this whole thing in my calculator. Log base 5 of 21 minus 4, and that comes up to negative 2.108. And that is my answer. If I put a negative 2.108 in here, it's not going to cause any undefined values, so we'll be fine there. Next one, I'm starting out 13 times e. Well, I'm going to try to get this thing as alone as I can. So I'm going to divide everything by a 13 to get rid of that 13 there. Well, 26 divided by 13 is 2. And then over here I get e to the x minus 5. The exponent's an x, so I want to get rid of this base e. And the way that I do that is by take the natural log, because I want the natural log to cancel out that e. So I just have the natural log of 2 equals, the natural log of e cancels everything out, and just left with x minus 5. Then I have to add a 5 to both sides. And when I do that, I end up with natural log of 2 plus 5 is what x is equal to. Now, you grab a calculator, you put natural log of 2 plus 5 in, and you get x equals 5.693. next one, so I have natural log of this. I can't really get that apart yet because it's the natural log of everything, so I'm going to get rid of the natural log by taking everything to the power of e. So the opposite of, what we did over here, we took the logs of both sides. So this has the logs, so I raise everything to those base powers. Now the e and the natural log cancel out, and on the left side of the equation, I end up with 2x minus 4 equals, on the right side, I just have e squared. Now this looks similar to other problems that you should know how to solve. I'm going to add a 4 to both sides, and then I get 2x equals e squared plus 4, and then I divide everything by a 2. And then you just grab a calculator and see what that gives you. Be sure that when you do this, the mistake would be to go e squared plus 4 divided by 2, just all in one motion. But unless you put parentheses around the e squared plus 4, that's only going to divide the 4 by the 2, not everything. So what I like to do is I'll put e squared plus 4, find an answer, and then divide that answer by 2. And the answer that I got is 5.695. Number 25, we're still solving, so we're still trying to find the value of x. So we're just going to kind of work our way to get that x all alone. First thing to notice is that negative 6, so if I add a 6 to both sides, that will move it over to the other side of the equation. And now I have this 3 log base 5 of x plus 9 equals 6. Now I'm still trying to get this x alone, so now I'm going to try to get rid of that 3. So I'm going to divide everything by a 3, both sides of the equation. So now I have log base 5 of x plus 9 equals 2. Now to get rid of that log base 5, I know that to get rid of any logs, if I raise it to a power, then the 5, log base 5, will cancel out. So I also have to do that over here. So I take 5 and raise it to the power of 2. So then I end up with x plus 9 equals 5 squared, or 25. Then I just have to subtract the 9 from both sides, and final answer is x equals 16. Just checking back in here, if you put a 16, 16 plus 9, still a positive number, not going to cause any problems, so this is our final answer. Moving on to 26. We have 2 logs now. So that's a hint to me that I need to condense them together so that I just have one log. I know how to solve one log. So they're being added together, so that means I'm going to keep the same base, log base 6, and I'm going to have the x multiplied by the x minus 5. And that whole thing is still just equal to 2. I'm going to go ahead and distribute that, so it's x squared minus 5x. So we have this problem right here, log base 6, better add that in. Now I want to get rid of this log base 6. So I do that by raising everything to a power of 6, both sides. The 6, the log base 6 cancels out, and I just have x squared minus 5x equals 36. Okay, now we have to think back to how we would solve this. in the past. And how we would do it is because we have an x squared and an x, we know that we've got to get everything on the same side. So we have x squared minus 5x minus 36 equals 0. Well, let's check first to see if this is factorable by doing the little x games. So negative 36 goes on the top, negative 5 on the bottom. Factors of negative 36 that add to get a negative 5 would be negative 9 and 4. So this then factors into, let's say, x minus 9 and x plus 4. Those are both equal to 0, so that means I have two possible solutions, x equals 9 and negative 4. Now if I check, if I put a 9 back in here, log base 6 of 9, yep, that's fine. Log base 6 of 9 minus 5, that still would be fine. But if I put this negative in here, you can't take the log of a negative number. So that makes this a extraneous solution. So your answer is just x equals 9. This one over here, we have a log on both sides. So how I'm going to solve that is I'm going to get them on the same side. So I'm just going to subtract 1, so that basically just turns that into a subtraction equals 0. Now I have a subtraction, which I know I can contract by using division. So I have this log base 3 of 2x plus 3 divided by 6x plus 4. This is all equal to 0. Now, I want to get rid of the log base 3. So if I raise that whole thing to a power of 3, both sides over here, this cancels out, and I just end up with 2x plus 3 over 6x plus 4. And 3 raised to the 0 power is just 1. Now, I got rid of the logs, but now I have a rational expression. And how do I solve that? I'm going to get rid of the denominator. So I'm going to multiply both sides by 6x plus 4. These cancel out over here, and I end up with 2x plus 3 equals 6x plus 4. Now it looks like a common equation that you've been solving for many years. Minus a 2 from each side, you get 4x. Minus a 4 from each side, you get negative 1. Divide by a negative 4. X equals negative 1/4. Now let's just plug that back into these equations, see if we get any negative answers. And this would be negative 2/4 plus 3, you're fine there. This would be negative 6/4 plus 4. No, that would be a positive answer totally. So that is your answer. And we are to number 28. What is the amount of time needed to have this much money grow here? So when we look at the equation here, time is going to be our unknown. A is the amount that we want to end up with, so that's 500. P is the amount that we started with, that's the original principal amount. And then we have E, the interest rate is 0.02 times T. So there's our unknown. Now to get that T all alone, the first thing we're going to do is get rid of the 300, divide by 300. 500 divided by 300 is 1.7 equals E to the 0.02 T. Now, I want to get rid of the E.